So part E, sum n equals 1 to infinity, n times x to the n over 3 to the n. Try getting started on this one by just, the usual, find the absolute value of an plus 1 over an. So start off by finding that, simplify it, and then we'll go from there. Are you guys getting what I have? Okay, what does that guy converge to? Does everybody see you're once again in that situation of having a rational function? And it's really only that one you're looking at because absolute value of x is a constant with respect to n. It's the limit as n goes to infinity. So what does n plus 1 over 3n do? It's a rational function, so you take the ratio of the lead coefficients to get that limit, which is really what? What are the lead coefficients? Because the degree of the numerator is the same as the degree of the denominator. Oh, so that the limit of just this guy as n goes to infinity is just 1/3, right? Oh, but then that constant's not going to go anywhere, so 1/3 absolute value of x. That's the limit of absolute value of an plus 1 divided by an as n goes to infinity. Now it's time to think about x. For convergence by ratio test, we need 1/3 absolute value x to be less than 1. Well, okay, to get rid of the 1/3, you could do that right away. What does the absolute value of x have to be less than? 3. Multiply both sides of this statement by 3. And then if you write this as just an inequality without absolute values, what does that mean? Oh, I better not use an arrow there. You'll confuse it with the arrow for converges. So this is the same thing as saying x is between -3 and 3. And that's most of your interval of convergence, most of it. But what do you have to remember to do? Check your endpoints. Okay. So if x equals, say, -3, you have to plug that in for x in the original series. And, well, what do you get if you do that? So we have the sum n equals 1 to infinity n times -3 to the n power over 3 to the n, like that. Well, okay, so how does that simplify? Well, okay, couldn't you think of -3 to the n as, so a little bit of scratch work here. Couldn't you think of this guy as -1 times 3 to the n power? And then you can split up the exponent over multiplication, not over addition or subtraction, but over multiplication and division. You could split this up, and okay, we still have this n, and you could make this -1 to the n power times 3 to the n, but then what happens with the 3 to the n in the denominator? Cancels. And so, I don't know why I switched to blue. And then so we get sum n equals 1 to infinity of, well, n times -1 to the n. Is that going to converge? It does alternate, but the bn is n, right? Certainly that's not decreasing, first of all. So that's one clue right there that it's not going to converge. So this is divergent. Now, when I say it's divergent, I don't mean it diverges to infinity or negative infinity. If you think about it, it alternates between numbers approaching infinity and negative infinity, right? So it actually doesn't even have a sum. We can't even say the sum is infinity or negative infinity. It's neither one. We just say it doesn't have a sum. But certainly the nth term test works here, right? It's obvious that, hopefully it's obvious that an does not converge to 0. So, well, I'll just put that parenthetically since I already said it's divergent. So are we going to include x equals -3? No. What's the other endpoint we need to check? So for x equals 3, what does that series become? Okay, so you plug in x equals 3, and what do we get? Yeah. So that's weird. Sum n equals 1 to infinity of n times 3 to the n over 3 to the n. So what do we get there? Sum of n equals 1 to infinity of just n. Is that going to converge? Diverges an, which is n, does not converge to 0. So it diverges by the nth term test.
Can we have one like that on the test?
Would the nth term test also work for when we tested -3?
Yeah, that's in fact what I was trying to indicate anyway, and that's why I wrote it down there in case it wasn't clear. So anyway, what's I here? -3 to 3, parentheses all around. What's R? Yeah, the difference between 3 and -3 is 6 divided by 2 is 3. So at least we got one where you didn't have R equals 1. I don't know, is this one any easier than the others?
Everything's easier with the test for divergence.
Ah, okay.